Hello friends, continuing with the chapter of atom, today we come to its sixth part, discovery of isotopes and neutrons. First we take up discovery of isotopes. It was year 1913 when Soddy proceeded to measure the mass of hydrogen atom using mass spectrometer. It was found to be three different values as 1.00785 units, 2.01414 units and 3.0160 units. Chemical properties of all the three were studied and were found to be same. Since physical properties relating to mass were different, hence these were termed as isotopes of hydrogen. H11 with mass 1.00785 units was termed as hydrogen. H21 or D21 with mass 2.01414 units was termed as deuterium, and H31 or T31 with mass 3.0160 units was termed as tritium. Thus, it was concluded that hydrogen gas has three isotopes which have same atomic number Z and different atomic mass, and isotopes were defined. I repeat, thus it was concluded that hydrogen gas has three isotopes which have same atomic number Z and different atomic mass, and isotopes were defined. That is, the atoms of same element having same Z but different A are known as isotopes. 1922 Nobel Prize went to Soddy for discovery of isotopes. Several isotopes. Practically every element possesses several isotopes. For example, chlorine has two isotopes with mass 34.98 units and 36.98 units, and mass of natural chlorine is 35.46 units. Now we have to understand about another term, relative abundance. So what is relative abundance? Let us try to understand. I define relative abundance as percentage of isotopes present in the given sample of an element in its natural state. I repeat, percentage of isotopes present in the given sample of an element in its natural state is known as relative abundance. For example, relative abundance of isotopes of chlorine atoms are as follows. Of 34.98 units is 75.4% and of 36.98 units is 24.6%. Now, mass of natural chlorine is equal to weighted average of masses of two isotopes of chlorine, and it is equal to 75.4 by 100 into 34.98 plus 24.6 by 100 into 36.98, and it is equal to 35.46 units, which is in accordance with the measured values. Assignment 12 continued. Question number 19. Define relative abundance. Calculate mass of natural chlorine if relative abundance of isotope with mass 34.98 units is equal to 75.4% and with mass 36.98 units is equal to 24.6%. Okay. So you calculate. Now, discovery of neutrons. Let us try to understand about theoretical prediction of neutral matter in nucleus. In 1920, 7 years later, Soddy discovered isotopes in 1913. Ernst Rutherford critically observed the masses of three isotopes of hydrogen atoms as discovered by Soddy-Fajan. Let us consider one by one. First, consider H11 with mass 1.00785 units. Since hydrogen atom contains one electron and one proton, the mass of one electron is 0.00055 units and mass of one proton is 1.00730 units. And when we add the two masses, it comes out to be equal to 1.00785 units. So thus it matches with the normal hydrogen. Now consider second isotope 2H1 deuterium with mass 2.01414 units. Now we can split it into mass of one electron as 0.00055 units plus mass of one proton as 1.00730 units and plus additional mass 1.00629 units. Now consider third isotopes 3H1 with mass 3.0160 units. It can be split up into the mass of an electron as 0.00055 units plus mass of one proton 1.00730 units plus 2.00815 units as additional matter. Now his arguments were as follows. Since number 1, charge on a proton is equal to charge on an electron. Number 2, number of electrons in an atom is equal to number of protons. Number 3, therefore atom is electrically neutral. Number 4, hence matter is electrically neutral. Now let us talk of additional matter. Since hydrogen atom contains one electron with mass 0.00055 units, therefore it must have one proton with mass 1.00730 units. And what about 1.00629 units in 2H1 and 2.00815 units in 3H1? This must be additional matter which must be neutral in character. Since matter is electrically neutral, atom is electrically neutral. In 2H1, the mass of this neutral matter is approximately equal to mass of proton, and in 3H1 it is twice the mass of proton. Thus he, that is Ernst Rutherford, theoretically predicted the presence of neutral matter in nucleus. Now experimental confirmation of presence of neutral matter. In 1932, James Chadwick confirmed the presence of neutral matter in the nucleus by bombarding beryllium nucleus with alpha particles. So what were the observations made by him? Some neutral radiations came out which could knock out protons from lighter nuclei such as 4He2, 12C6 and 14N7. So these are protons which are knocked out from these lighter nuclei. Now these radiations possessed energy higher than the bombarding alpha particles. Now conclusion drawn. These high energy neutral radiations consist of neutral particles called as neutrons. I repeat, these high energy neutral radiations consist of neutral particles called as neutrons. Now mass of neutron. If neutrons are present in nucleus, then question rises, what is the mass of neutron? and then mass of neutron was measured. How the mass of neutron was measured? Let us see. The mass of neutron was measured by James Chadwick by comparing velocities of hydrogen and nitrogen atom after a neutron had a head-on collision with these atoms. Now let us see how it had been. Physical situation. Let m be the mass and v be the velocity of a neutron which has a head-on collision with hydrogen atom at rest. This is hydrogen atom at rest. This is neutron which had a head-on collision with hydrogen atom at rest. Now let mp be the mass of hydrogen atom and up be its velocity after head-on collision with neutron, and v dash be the velocity of neutron after collision. Now we are to apply law of conservation of momentum. If neutron velocity be v dash after collision, then according to law of conservation of momentum, we have mv plus 0 is equal to mv dash plus mp into up. Let us mark it as equation 1. Now we apply law of conservation of energy, and according to law of conservation of energy, we have half mv square plus 0 is equal to half mv dash square plus half mp up square. Let us mark it as equation 2. Now elimination of v dash. Now eliminating v dash from equation 1 and 2, we get up is equal to 2mv divided by m plus mp, and substituting the value of mp as 1 unit, we get up is equal to 2mv divided by m plus 1, because mp has mass equal to 1 unit. So we replace mp by 1. Let us mark it as equation 3. Now similarly, velocity of nitrogen atom was determined by bombarding with a neutron, and then in the same way we can write it as un is equal to 2mv divided by m plus mn, and when we replace mn, we put in place of mn as 14, because 14 units is the mass of nitrogen atom. So therefore un is equal to 2mv divided by m plus 14. Thus velocities of hydrogen atom and nitrogen atom was measured. Let us mark it as equation 4. This is how James Chadwick measured the velocities of hydrogen atom and nitrogen atom after head-on collision with neutron. Now dividing equations 3rd and 4, we get up by un is equal to m plus 14 divided by m plus 1. Let us mark it as equation 5. James Chadwick measured velocities of hydrogen and nitrogen atom after collision and found up is equal to 3.7 into 10 raised to the power 7 meter per second and un equal to 4.7 into 10 raised to the power 6 meters per second. Now mass of neutron. Substituting these values of up and un in equation 5, we get 3.7 into 10 raised to the power 7 divided by 4.7 into 10 raised to the power 6 equal to m plus 14 divided by m plus 1. After simplification, the mass of neutron was calculated to be as m equal to 0.911 units. Now measured with highly sophisticated equipments and is found to be 1.00866 units. Thus mass of neutron was found to be as 1.00866 units. This is how the mass of neutron was measured. Now free neutron is unstable. It decays into a proton, an electron and a neutrino. That is N10 when decays, it decays into a proton 10 plus electron plus a neutrino. Okay. So this is how the mass of neutron was made by James Chadwick. Assignment 12 continued. Question number 20. State the contribution of Rutherford in discovery of neutrons. Question number 21. How James Chadwick proceeded to confirm presence of neutral matter in nucleus of an atom. Question number 22. How mass of neutrons was measured by James Chadwick. Question number 23. Free neutron is unstable. What happens if it is free? Thank you so much. Next time we'll start with next chapter, nucleus. Till then, goodbye and good luck to you.